Okay, so this is your lesson for Thursday, April 2nd. Wow. I'm going to do one additional problem from arithmetic, and then today's lesson you are going to be learning, which is 12.3, we'll be learning about now our geometric sequence. But again, before we get to doing that, yesterday, or I should say Tuesday's lesson, I taught you guys arithmetic sequence, and I taught you 4 different types of questions I could ask you. Today is the 5th example that I could kind of ask you, and it's going to help you for a future problem. So the question is going to say, find the, it's blurry, there we go. Number of terms in the following arithmetic sequence. Now, when you guys see the word or the phrase, find the number of terms, I need the light bulb to go off and for you to automatically always think, oh, I'm finding n. N is the number of terms. Like if I said a sub 20, remember, a sub 20 means the 20th position or the 20th term is something. So when I say find the number of terms, I want you guys to always be finding me n. So here's your first question. Okay, well, there's your question. Here's your example, I should say. 9, 4, -1, -146. So what happens here is I gave you guys the first 3 terms, right? A1, A2, A3. You can see that there is a common difference of the pattern, and then all of a sudden you get to -146. I want to know how many terms there are in this sequence. But it's a problem because I don't even know how many there are. I know I have 1, 2, 3, something, 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 and then I don't know. So here's how you guys are going to find it. Just in case, so I can ask you again to find the number of terms, or I can also ask it this way. What is the position of ... And in this case, it's what is the position of -146. All right, so here we go again. Anytime you guys are dealing with arithmetic sequence, I need you to write your formula. And again, you want to write it so you have the memorized, and then all you're doing is inputting the values that you know. All right, we all should know that a sub n, let's write this again to review, is, we could say, the last term if you want for now. We all know A1 is my first term. Oopsie. We all know D is the common difference. And N, we can say, is now the position, or star this, the amount of terms. Really, again, what n is whatever's position this term is. So if this is 5 and this was 60, then what that means is the 5th position or the 5th term is 60. So we don't know this. This is what we're going to look for. And again, it means the amount of terms. So when you hear this question, I want you always thinking you're going to be finding n. Well, once you know that and I give you information, again, here you go. With the formula, you're inputting the values that you have above. All right, so let's see what we have. You always want to put what you have. A sub n is the last term. Well, in this case, there you go. -146 is the last term. A sub 1, first term. There you go, the first term, plus, well, the common difference. So here we go again. I mean, it's easy for you to visually see, but if you wanted to do the common difference, you take the second term minus the first term. Again, I'll write that down. I know you guys like me writing notes. So second term minus the first term, you guys end up getting a -5. Obviously, it's negative because you are getting smaller. So -5, and then here is that n minus 1, because I do not know, again, what term -146 is. The question is what is it? How many terms is in this sequence? This sequence stopped. You have sometimes finite sequences and infinite sequences. This sequence stopped at -146. So in this sequence, please understand that this is my last term, which is why I referred to this, a sub n, as my last term. A sub 1, first, d, common difference, and the n is the amount of terms. So with that in mind, you have all your values. Now we're just going to solve. So be really careful here. The reason I say be really careful is, remember, I know your mistakes. A lot of people want to do this first. You have to follow PEMDAS. PEMDAS tells us first we have to distribute. So be really careful. Very common mistake for a lot of kids to do 4. Well, and then once you do that, you should be fine. So now you have 9 plus 5 is 14 minus 5n. That's minus 14 from both sides. You get -160, running out of room, equals -5n divided by -5 divided by -5. So n is 32. Now let's just, again, just make sure you understand what that means. What this means is -146 is the 32nd term. Again, since this sequence, think of this as like a period here. Since this sequence has ended, it means this was the last term. So how many terms are there? 32 terms. 32 terms are in this sequence. Okay, let me just show you one more. Again, this is going to be very helpful when we start to learn something called series. So this is the same type of example. Let's just show you one more time. -20 is what term in the sequence 38, 36, 34, ... -20, question mark. So here we go again. I want the light bulb to go off. When I ask you what term, I want you to always think, okay, I'm finding n. I do not know how many terms there are. So one more time, let's write our formula. Okay, here we go. A sub n is the last term. This is my last term in my sequence. A sub 1 is my very first term. So the common difference, I'm going to take my second term minus my first term, and I get a -2. So my common difference, I know you guys can just visually see that, but I just want to keep reiterating the rule. And then here we go, n, which I don't know, -1. Please, please be very careful. Do not do this first. You have to distribute that 2 out. And then from there, you guys should be fine, and you should get n equals 30. Again, what does that mean? That means that this -20 is in, if this is the first position, second position, third position, ... -20 would be the 30th position, the 30th number in this sequence, which means 1, 2, 3, blah, 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 etc., 30. There are 30 terms in this sequence. So this should be a pretty simple question for you all. Okay, so now let's start our geometric. So how do we do geometric? Okay. So sorry, let's just readjust. Geometric is pretty simple. There's not many questions I can ask you guys for geometric. So we're going to do geometric. I know it's in and out of being blurry. So geometric sequence. So here's what our definition is going to be. It is going to be a sequence in which each term, again, after the first term is obtained by. Now, just so you understand the huge difference, the other time when I talked about arithmetic, I told you it was obtained by a common difference and by adding or subtracting. This one is obtained by multiplying. By, the previous term this is now going to be called, sequence in which each term after the first term is obtained by multiplying by the previous term. Again, it is a constant or a fixed number that's not zero, and it is called sequence in which each term after a common ratio. Not sure if that got a little wordy, but hopefully you guys all know what I mean. And the letter we use is an R. The letter we use for a common difference was a D. Common ratio is an R. The way, again, you find the common ratio, just like you found the common difference, you're going to take the second term and divide it by the first term. This gives you your R. The D was the second term minus the first term. So here you go again for your first example, just like you would have for your homework. The question is going to say, are the following geometric sequence? Something like this. So again, they are if each term you're constantly multiplying by the same number, which is the common ratio. So here is the example. 4, 10, 18, 40. So what I would like you to do again is to get in the habit of taking the second term, dividing it by the term before it. If you do that, you would get 2.5. All right, let's see about the next one. If I take 18 divided by 10, I get 1.8. The common ratio is not the same. So no, this is not a geometric sequence. All right, now let's try 125 and 25. So what we would have here is if I took 125, again, the second term, and I divided it by 625, you would get 0.2. If I took 25 and I divided it by 125, I get 0.2. Common ratio, so yes. Yes, this one is a geometric sequence. Okay, so that's the first type of question I can ask you in your homework assignment. And then here is the next one. There are 3. Sorry. Not as hard, though. I forgot the word by. So a sequence in which each term after the first term is obtained by multiplying by the previous term, by a constant. Multiplying. Yikes. I don't feel like redoing this video, so just leave it like that. Sequence in which each term after the first term is obtained by multiplying the previous term by a constant or a fixed number. Sorry, long day. Okay. So now the question is, what is this rule? Just like the arithmetic, you have the geometric rule, which is why I wanted you guys to write it down so many times so you have that memorized so you won't confuse this with the geometric rule. Same thing, let's write it and then I'll explain. So here you go for your geometric rule. Geometric rule is a sub n equals a1 r, and then you want to raise it to n minus 1. All right, let's talk about what each one of these are again. Well, we know what a sub n is. A sub n, again, is what we call our last term, you can say the term we are finding, and so forth. We talked about that one the other day. A sub 1, we all know, again, is our first term. Here is that n again. Remember, this n and this n, they are the same n. Please be aware of that. So if we remember, n is the position or location. And then here you have your new one, which is r. R is now the common ratio. And one more time, the common ratio can be found by you guys taking A2 and dividing by A1. That is your rule, just like we did for arithmetic. Now let's take a look at one of our examples. So I'm going to label this number 2. You are going to use this as number 2's example in your homework. We're going to do 2 of these again so you guys can get the idea of the question. So here we go. It's just like arithmetic. I'm going to say to write a rule for the nth term. Again, rule meaning explicit. That'll make more sense when I teach you the other one. Of the geometric sequence. You could say, and then find, we'll say a sub 7. So that means your 7th term. All right, so here you guys go. Let me give you guys the numbers. So first sequence, you got 4, 20, 100, 500, ... So obviously this sequence is going on. I'm not asking you guys for that. So here we go, like I stressed to you last time. You know it's a geometric sequence, so let's start writing down our geometric rule. A sub n equals A1 r n minus 1. It should be helpful. All you have to do is substitute A1, which is our first term, yay, of 4, now times the common ratio. So to find the r, I want you to take the second term and divide it by the first term, always. And 20 divided by 4, we all should know, is 5. So my ratio is 5, n minus 1. This is your explicit formula. Please, please, the other thing, do not multiply these. If you recall, again, PEMDAS tells us exponents. So if you were to do the operation, it would be 5 raised to whatever power was here, then times 4. Again, do not multiply. It's very easy for you guys to do that, so be really careful. Then if I ask you to find a sub 7, well, you do the same thing you did again. 7 means substitute that in for wherever you see n. So it'd be 4, 5, and then 7 minus 1. If you had a calculator, you use a calculator, but please understand. Again, you're doing 7 minus 1, which is 6. 5 to the 6th, then you times it by 4. And if you do it in the calculator, you will get 62,500. And let me just emphasize this one more time. Running out of room. It's 5 times 5 to the 6th. So please make sure you guys understand that the geometric, I think, is a lot easier than arithmetic. It's pretty much you just substitute, write the numbers in. Okay? Let's try one more just like this, and then I'll show you guys one